Hello everyone, welcome to today's session. In the last session, we wrangled our data. So my next step is training and testing your data. So here we will split the data set into train subset and test subset. And then what we'll do? We'll build a model on the train data and then predict the output on your test data set. So let me just go back to Jupyter and it is implemented this as well. So I need to train my data set and I'll just put this indeed heading 3. So you need to define your dependent variable and independent variable. And here my y is the output for you can say the value that I need to predict. So here I will write Titanic ship data. I'll take the column which is survive. So basically I have to predict this column whether the passenger survived or not. And as you can see, we have the discrete outcome, which is in the form of 0 and 1. And rest all the things, we can take it as a feature. Or you can say independent variable. So I'll say Titanic ship data, not drop. So we just simply drop the survive and all the other columns will be my independent variable. So everything else are the features which leads to the survival rate. So once we have defined the independent variable and the dependent variable, next step is to split your data into training and testing subset. So for that, we will be using sklearn. I just type in from sklearn.model selection import train test split. Now here, if you just click on shift and tab, you can go to the documentation and you can just see the examples over here. And I click on last and open it. And then I just go to examples and see how you can split your data. So over here, you have extra next test y train, y test, and then using the train test split and just passing your independent variable and dependent variable and just define a size and a random state to it. So let me just copy this and I'll just paste here. So here we'll train test. Then we have the dependent variable train and test, and using the split function we'll pass in the independent and dependent variable and then we'll set a split size. So let's say I'll put this as 0.3. So this basically means that your data set is divided in 0.3, that is in 70 by 30 ratio. And then I can add any random state to it. So let's say I'm applying on this is not necessary. If you want the same result as that of mine, you can add the random same. So this would basically take exactly the same sample every time. Next, I have to train and predict by creating a model. So here logistic regression will graph from the linear regression. So next I'll just type in from sklearn.linearModel import logistic regression. Next I'll just create the instance of this logistic regression model. So I'll say log model is equal to logistic regression now. I just need to fit my model. So I'll say log model dot fit and I'll just pass it in my X train and Y train. It gives me all the details of logistic regression. So now what I need to do? I need to make prediction. So I will take a variable prediction and I'll pass on the model to it. So I'll say log model dot predict and I'll pass in the value that is X test. So here we have just created a model fit that model and then we had made predictions. So now to evaluate how my model has been performing, you can simply calculate the accuracy or you can also calculate a classification report. So don't worry guys, I'll be showing both of these methods. So I'll say from sklearn.matrix input classification report. So here I use classification report and inside this I'll be passing in y test and the predictions. So guys, this is my classification report. I have the precision, I have the recall, we have the advanced code, and then we have support. So here we have the value of precision as 74 and 74, which is not that bad. Now in order to calculate the accuracy as well, you can also use the concept of confusion matrix. So if you want to print the confusion matrix, I will simply say from sklearn.matrix, import confusion matrix first of all, and then we'll just print this. So how mi function has been imported successfully. So I will say confusion matrix, and I'll again passing the same variables, which is y test and predictions. So I hope you guys already know the concept of confusion matrix. And if not, I can just quickly summarize this as well. So I'll just tell you in a brief what confusion matrix is all about. So confusion matrix is nothing but a 2 by 2 matrix which has 4 outcomes. This tells us how accurate your values are. So here we have the column as predicted no, predicted y, and we have actual no and actual yes. So this is the concept of confusion matrix. So here let me just fade in these values which we have just calculated. So here we have 115, 24, 26 and 70. So as you can see here, we have got 4 outcomes. Now 115 is a value where a model has predicted no, and in reality it was also a no. So where we have predicted no and actual no similarly, we have 70 as predicted yes. So here model predicted yes and actually it was yes. So in order to calculate the accuracy, you just need to add the sum of these two values and divide the whole by the sum. So here these two values tell me where the order has actually predicted the correct output. So this value is also called as true negative and this is called as false positive. This is called as true positive and this is called as false negative. Now in order to calculate the accuracy, you don't have to do it manually. So in Python, you can just import accuracy score function and you can get the results from that. So I'll just do that as well. So I'll say from sklearn.matrix import accuracy score and I'll simply print the accuracy. I'm passing the same variables. That is why I test and predictions. So it tells me the accuracy as 78, which is quite good. So if you want to do it manually, we have 2 plus these two numbers, which is 115 and 70. So this comes out to almost 185. And then you have to divide by the sum of all the numbers. So 115 plus 70 plus 24 plus 26. So this gives me the result of 1 by 4. So now if you divide these two numbers, you will get the same accuracy, that is 78%, or you can say 77. So that is how you can calculate the accuracy. So now let me just go back to my presentation and let's see what all we have covered till now. So here we have first data into train and test subset. Then we have built a model on the train data and then predicted the output on the test data set. And then my fifth step is to check the accuracy. So here we have calculated accuracy to almost 77%, which is quite good. You cannot say that accuracy is bad. So here tells me how accurate your result. So my accuracy is good, fine. That enhanced got a good accuracy. In the next session, we'll work on our next project. If you guys have any doubt, you can ask your doubt in our comment section. Thank you so much for watching.